So we're here with the AMSYSTEMS right here. Hello, so who are you?
I'm Wijnand Germs. I'm a program manager for 3D printed structural electronics at AMSYSTEMS Center.
And what are you looking at here?
Here we're looking at our latest demonstrator to actually demonstrate the combination of 3D printing with printed electronics technologies. So this is the head of a gear shifter, and you see here that the electronics is in a very small volume, and each number has its own LED, so it shows also if you would place sensors you can have complexity in a very small volume there of your product.
So this could be reliable and used as a gear shift?
This is one of the first that is made. It is of a material that has sufficient strength for dental implants, so I think so, yeah.
So very strong 3D printing is possible?
Well, very strong. Of course, 3D printing is known that it's a little bit less strong often than in mold of molding products. But yeah, the quality has improved a lot lately. Yeah.
And what you're showing here is a knee. Let me jump over here.
Yes. So this is an implant with a sensor in there. So these kind of implants, when you have them in your knee, then at some point they have to be replaced. And this is actually measuring with sensors whether it's actually necessary to already operate somebody.
How would it measure?
There's a sensor in here that would then...
Put it in the knee?
Yeah, so first you already put it in your knee if you need this implant, and then it actually measures the pressure locally to see whether it should be replaced or not.
So that's again a combination of 3D printing and
and embedded electronics in it. Yeah.
So that's your specialty, to do hybrids?
Yes, that's our specialty. We develop equipment concepts for this. So this equipment is not yet in the market to combine it with these 3D printing technologies.
And here, is this USB sticks?
Yes, these are USB sticks with the flash drive and also an LED. These show actually the small series manufacturing that you can easily change the logo to your company and also adapt the electronics to it. So you don't need a new PCB, just rearrange your electronics.
So you have all these demos right here with different logos?
Yeah. And these are SLS printed and these are SLA.
And are you putting a chip inside the... What is this?
Yes, so this is just a chip to show you the pick and place and what you could think of also for complexity. So could also have large chips in there.
This could be a big ARM processor.
Yeah.
To do what?
Anything you can imagine, of course. We can go to higher and higher complexity. Maybe already computing the sensor data that's harvesting. So,
computing the sensor data, there should be a lot of other electronics too, right?
Yeah. So this is just showing the concept of pick and place something in 3D printing.
Nice. You have a big machine that can do this?
Yes, we have. So that's the machine is not here.
No, just.
But we have a movie also online with a large stereolithography machine that we developed, and so this platform is made to do multi-technology manufacturing. So also combining it with extrusion, post-curing of conductive tracks, pick and place. That is so one stop for your whole digital design should go in there, and then the final product should come out. So this is still in development, but we're already quite far with it.
So is it the coolest 3D printer in the world?
Yeah, it is definitely the coolest. Yeah. Also,
and you designed it?
I didn't design it personally. My colleagues, we did it all together, of course.
How many colleagues do you have?
Well, we're in a group of 30 people, and with all kind of disciplines. So we're working on this. Yeah, it's really a team effort. Yeah.
And it's all about doing hybrid, future 3D printing, future the useful 3D printing, right? You're making teeth.
Yeah, so it's actually all directed at the industrial additive manufacturing, as we call it. So these teeth, these ones actually show multi-material stereolithography. So here on the back side you can see they have actually two materials, and actually depending on the thickness of this outer layer, it changes the color of your teeth.
Oh, so you can have yellow teeth.
Yeah. If you have yellow teeth, it's better to have a yellow crown next to it. Yeah.
So you can analyze all the other teeth and match.
Yeah.
That's amazing. Do you have this happen for real now?
No, it's not happening yet. So these crowns, they are available, but usually people put it in the back of their mouth. There, it's acceptable to have a somewhat color difference. But when it's in front of your face, then it has to match better in the color.
And it's ready to match?
No, this is also still in development. We're working on this with a couple of industrial partners. Yeah.
So soon.
Yeah, we hope it will be soon available soon.
So people can wait another couple years before they go to the dentist, and then there'll be this solution from you.
Hopefully.
This is all printed in one go too, right?
Yeah, there was no assembly here, so it was printed with SLS. Only the powder needs to be removed, and you can actually see that you can have it drive. So just catch it there.
Oh, you guys.
Yeah.
And what are you doing with those shoe soles?
So these shoe soles, they have a structure in here that actually makes the mechanical properties anisotropic. So it can be more flexible in this direction, but less flexible in this direction.
Oh. So that's the structure of those things there.
Yeah. So you, in this case, only require one material here, but you have different properties.
So I guess in your labs, you've broken a lot of things, right? While you were testing.
Yes, of course.
Off and you're like, oops, let's do another one.
Yeah, of course. Everywhere where you try new things, also some things can go wrong. And of course, we're looking for the boundaries of what is possible and whether we can shift those boundaries. Yeah.
Are you measuring the strength of what you do? You have machines for that?
Yes, we also have machines for that. So for that also we have other departments and other institutes from TNO, so like the Brightlands Materials Center next door. Yeah. So we're from the same mother organization. Yeah.
And what were you speaking about? You had a speech, right?
Yes.
So what are you speaking about?
Well, there I also actually showed what we are able to do now, why you would want to 3D print with embedded electronics. And so this is actually showing the free form aspect of it. The USB sticks more the small series manufacturing. And I think in general, using these technologies, it would increase your flexibility also for having a wider product portfolio and a faster change. You can faster change your product in this way because you don't have product-specific tooling.
So the future of the world with 3D printing is going to be different than the past?
Of course, something should be different, otherwise we wouldn't work on it. Of course, the existing technologies, they also still have their use, but this would definitely change things for product portfolios, yeah.
So you're speaking with lots of people all over the world?
Yes, yeah.
And they are asking for more and more different things, and you can do it?
Of course, people also ask for things that we cannot do, and of course the challenge is to do as much as possible and always do new things again, yeah.
So what did they ask you cannot do?
Well, one thing I heard today was actually micro channels of 1 micron width to print them in 3D. And so that's, at this point, a step too far. But who knows in the future.